Alright, so the basics of advanced programming in C++. Okay. At this point, you have seen more complicated programs than this one. Alright, so this is as basic as it can get. Just displays that and returns. Alright. So the first thing I want to talk about is this return value here. Okay. This is the value that is returned to the program that called this program. So if we run, this is this value here, return 0. If we make this value to be 5 and run it again, we're going to see the process return 5. Alright, so 0 means no error, successful. Any other value is for errors. Okay, so a question. Is this the smallest program in C++? Like, is this the most basic? The answer is no, and I'm going to explain why. So the first reason is we do not need to specify this. Okay, so we can get rid of that, and if we run, the compiler is going to be smart enough to append 0 there, so that can go, and we don't need this using namespace std. Okay, we can get rid of that, but if we do, we need to append std here and std there. Okay, so if we run this, we're going to notice no errors. Okay, all right. We can keep on removing things, so we can remove this part. We don't need our program to display something. Okay, and since we are not using any cout, we can get rid of this part as well. Okay, and we can run. It does execute successfully. It doesn't do anything, but still it is a valid C++ program. Is this it? No, we can still get rid of this int here, and the compiler is going to be smart enough to append all those things. So if we run, there we go. And this is as little as basic as we can get. Okay, so this is the most minimum requirement for a C++ program in a GCC compiler. Okay, all right, so if I'm to return the things that I had here, then if I have that, and I will say ready, return 0. Alright, so if we run that, it says ready, we are good to go. So the first thing, well, that is going to be a second thing. A second thing I want to show you is what is this thing here when it says include Iostream. We know this is what is called a header. You are including a header here because you're using something in your program, cout and endline, things that have been defined by other people. Okay, other people have written code that has the functionality that displays this text to the screen. So you just want to reuse that functionality here. So actually you can see what this piece of code looks like. So that is what I want to show you next. So if you can go to alright, I'll go to this PC and I can go to the location where code blocks is installed. If we go in there, min gw, if we go to lib, gcc, min that, if you go inside include and inside C++. Alright, now I want to open this folder. I can open this folder in Visual Code, but Visual Code doesn't highlight the code well. The file doesn't have a extension, so I'm going to use Sublime for this. Alright, so I will open a folder, and it is this folder here, C++. That's the folder I want to open. So let's look around. Here we have all the common headers that come by default with your installation of C++, and all the headers that you usually get rid of this. You usually include at this point will be found there. So let's begin with Iostream. This is Iostream here, and you can see it is just another C++ file. It's a header. It has a number of things, but nonetheless it is just a piece of code that other people have written. And you can see itself, it has a number of includes. The two I want to point your attention to is this Iostream, O standing for output stream, and input stream, because Iostream is input and output stream. Okay, so it includes these other files, and all these files are here. So you can see Iostream is right here and Iostream is right here. So if we scroll down a little bit, you see this thing called namespace std. So that namespace std you include here. Std, namespace is a way of grouping code. Okay, so if I can go back here and I can open another file, let's say Iostream. Here you can see it has namespace std. So we have this a group of code, a group of functions. You can see here functions, variables, and other things that are grouped under the same header of std, and it spans multiple files. So some functionalities, some functions, some variables are defined in this file, some are defined in this file, and many others. Okay, so when you come here, this is a way of telling the compiler that I want to use the functionality inside this group of code called std. Okay, and what this enables is for programmers to define variables or functions having the same names but belonging to different groups. Okay, can have the same name but it can belong to different groups. So every time you want to use a certain function, you have to be explicit to the compiler that I want to use cout belonging to this group of code called std. Alright, so back to Iostream. So inside here you can see it defines this, it declares. Extend just means we declare this variable here, but it is going to be defined in another external file. So it declares this variable here, cin and cout, and you can see the comment here. It says this is going to be linked to the standard input. Usually by default that is the keyboard, and cout is the standard output, which again by default is the screen or the terminal. And standard error, the stream for writing the errors, and by default this will be connected to the screen or the terminal as well. And you see other number of variables here. So it is very short file because it also includes other things here. So let's look at one of these. Let's say Iostream. You see the same thing, that it declares that these functions, variables inside here, they belong to this group of code namespace called std. And if we look around, Let's see if there's anything interesting that we've used so far. We see a definition of this operator here. This is telling the compiler what to do when this class here is used with wait, are we inside the class? Yeah, inside this class. So this class here, what happens if an object of that class is used together with this operator here? Usually you have something like that is input stream. So let's say if we have int age and we do something like this. So this operator here is used together with this cin object. Okay, so there is where you define the kind of behavior that you want to deal with that kind of usage. And when you start writing your own classes, you can define your own things as well here. Okay, like this, you can define how your object should handle when this operator here is used, or this kind of operator here, or a plus, for instance, or a minus. What does it mean? Okay. Maybe I can provide a quick example. So you can define an object called student, and let's say we define a variable called stud1 and stud2. Okay, student1 and student2. So let's say we want to define a behavior like, what does it mean to do something like this? Stud1 plus stud2. What does this mean? So you can define the plus operator with your function. Okay, so that you can capture this kind of behavior. Getting off track a little bit, but you can see here my point is the Iostream, all these headers, they just define variables, functions, and other things. Okay, and probably one of the other header we have seen so far is this C standard lib. Let's look at that, because we used the exit function from this library here, and you can see similarities. It includes some other headers as well. It defines these two things, exit success and exit failure, and you can actually use this. So let me show you. Like if you do something like this, include C standard library, and I'll comment out this so that it doesn't have to ask us, and instead of saying return 0, you can say return exit success, like that. Okay, because exit success in this C standard library is defined to be 0. So if you run that, you'll see it returns 0 just. Okay, so if you ever saw this somewhere, there's where it comes from. So it defines variables like that. It defines this function exit, and it defines this other function called @exit. Maybe I can show you an example of how to use that. So let's say we define a function here. It's called goodbye, and what this function does is to just say see you. Okay, and then what you can do is you can define here, you can tell the compiler that the time when this program is exiting for the very last time, I want you to call this function. One use here can be like, let's say you create a program that interacts with resources like files, database, or it opens connections to other programs or computers. And then you want, when the program is quitting for any reason, to clear out or to close those files or those resources, to close database connection and things like those. Just some cleanup of some kind. Or maybe you want to report something, the sky is limit. So at the end of this program, call this function goodbye. So if we run now, you'll see we call goodbye before cout, but here is not when the goodbye is going to be called. You can see here cu comes after ready, because actually the cu is called at this point. Just before you return, just before you exit, then we can call that. And curious behavior, let me show you something else. Let's say we'll call it close. Okay, maybe this function is closing things, and say closing things, and you can call it multiple times. So I can say here at exit, call close. Notice the way I put the function here. I just put the function name. Okay, so if I close the other one, if I run this, so what's okay, I have a wrong name here. Alright, now can you notice something? Notice the order that these functions are being called. The first function we registered to in at exit is goodbye and then close, but you can see here it called close first and then it called goodbye. And the reason is all the functions you call, you register in this at exit, it is put in a stack, and a stack, like a pile of plates, the last thing you put in will be the first thing to come out. So just remember that. So back to the this library here. So it does define a number of things, and including the function exit itself. So let's say at this point, if I just run exit, and exit expects like an exit code. If I run it at that point, notice that it never reached the ready. At this point, we just terminate the program, but still it's going to call these two functions, because we always say when you exit, call those two functions. This is different to this other function that you see here, which is abort. So I'll come here, and instead of exit, I'll call abort, and notice what is going to be the difference here. You see, it says something like the program has stopped working and all these things, blah 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 blah. And one of the things you need to notice is that it never called this at exit. And the reason the Windows picked up that, let me run it again. The reason this, you see this, the program has stopped working, something you don't see when you call exit, is because, among other things, when you call this abort function, it sends the signal abort to the parent process that called this program, as a way of, a distress signal, like something went wrong we are quitting, and we are quitting in a weird way. So exit is like a very graceful way of closing this program, and abort is not. Okay. Alright, so back to more of these, and you can see here it defines other things as well. Yeah. The other header we have seen is F-stream, which is the header that enables us to interact with files, to open files, to create files. And you can see itself, it uses the input and output streams, and it also belongs to the standard namespace. And let me see if we are going to notice anything we have used so far. Is open. We have used this function in one of the challenges to check if, as you can see here, to check if a file, if that external file is open, was opened successfully. And we can see other things, the mods here, different mods, like you can open a file so that you can write to it, or you can open a file as a read-only file, so you cannot make any changes to the file. You can open file in like append mode, so it is just going to add at the end of the file itself. The open function, we have seen that as well, and a close function, we saw it. So just want to show you that there is no magic here. All the things that you use here in your programs, they come from somewhere, and this somewhere is these pieces of code that other programmers have written, and you can write your own. And let me show you actually at this point. Let me show you right now. So let's say these two functions, okay? Instead of defining them here, let me define them in like a separate file or something. So if I can create a new one here, let's say my header dot h. It's just a typical extension that we usually use for headers. And even though there are like best practices for the best way to write these headers, but for now I'll just just be sloppy and show you just something that works. Okay, the name of my header is my header.h. I have it in the same location with test, so I can just do like my header, and notice I'm using quotation marks. So it is the practice that for the headers that you define yourself, use the quotation marks, and for those that come with C++ by default, use the angle brackets. So if I save this and run, you're going to notice there is no difference. It executes exactly the way we expect it to. So that's the headers, nothing magical there. So back to this. So this libraries define, as I said, the different functions, classes, variables, and it also organizes like code in groups called namespaces and other things. Another library that you're going to be using all the time is Seamoth, and as you can guess, it includes a lot of functions, variables, constants that are used from time to time with mathematics, and it includes the its corresponding C library for mathematics. And this C library, actually, let me show where that is. It's if you can go to programs, code blocks, main GW, include, then here you're going to find the math.h. If you open up this quickly, you can see it defines a lot of things, but things of interest, among other things, are these constants here. So you can see the value of pi right there. I'll show you how you can use this in a program. And this is the value of e, the 2.718 constant. This is the value of logarithm of e to power to logarithm of e to base 2, and this is logarithm of e to base 10. This is the natural logarithm of 2. This is natural logarithm of 10. That's the value, and the value of pi itself, pi divided by 2, pi divided by 4. This is the value of reciprocal of pi, 1 over pi. This is 2 divided by pi. This is 2 over square root of pi. This is square root of 2. And this is the square root of 1 over 2. So one way, let's say you want to get this value of pi, so you have two options. You can include the Seamoth header, even though the value of pi is defined in math.h, but as you could see here, the Seamoth header also includes math.h. So we are covered there, and we can come here and instead of this I can say that, and you're going to get the number here. Notice that the number of decimal places here is way smaller compared to the actual value here, which is displayed there. And the reason is at this point the compiler is going to cast this number to a float, and we are not limiting the default. We are not changing how many decimal places should be displayed. So in the coming video we are going to see how we can change that using the manipulation, input-output manipulation header. So that is a constant, and if you want to get a something like maybe sine of 2 times pi, so we can do this, and if we run that, you're going to get that, which is essentially like 0. Let me do sine of that, and we have that. Cosine, if we run it, see it is -1. So such things. I was here. So it defines a number of constants like that, and if we can go back to this one, it has all these other functions, the inverse of sine, ceiling, and flow. These two functions are interesting. Let me give you an example. So if we say instead of this, I do flow of 4.7, okay, and also the ceiling of let's say 3.1. So what are these values? The floor is the smallest integer which is equal or greater than this value, and ceiling computes the biggest integer which is equal or less than this value. So the answer here is 3, and no, the answer here is 4, and the answer here is 4 as well. So remember, floor just computes the biggest integer which is equal or less than this value, and ceiling is the smallest integer which is equal or greater than this value. So you can see it is 4, 4 in both cases. So this is not approximating, because if you approximate 4.7, that is 5, and if you approximate this, that is 3. And these two functions can enable us to do something interesting. So let's say we want something like let's say we define I define a number like 5.8, okay, and I want to get to separate the integer part and the fraction part, the decimal place part. So I want to get 5 and also want to get 0.8. So to get a 5, that is simple, we just use the floor, okay, that is going to give you 5. Then how do we get the 0.8? You can combine you can use the floor in a tricky way. So we can do something like this. We can take the number itself and subtract the floor of that number, and that will always give us the fraction part. So as you can see, it's 0.8. So here it defines other functions as well. Exponent is a value of a number raised to base e, so it is e raised to that number. If you want to get any other power, like if you want to get 2 power 10, you need to use this power function. And you can see here log, this is actually a natural logarithm. So this is log of a number to base e, and if you want the log of a number to base 10, you use this. So this is log of a number to base 10. And let me see if there is another interesting functions. Oh yeah, square root and tanh. Yeah, and these are the things here. So all these libraries will have all these functions, and as a reference there is this cool website here, C++. Yeah, and if we can go to the reference, you can see all these libraries. Okay, it is going to tell you what the library is as a summary and other information as well. So let's look for Seamoth as an example, because we've already seen that one in detail, and it's going to describe like different functions that are in that library and a summary of what that function is, and a category here that this is a function. And if there are other things like all these constants, see here, there is even a constant for infinity, so it defines all of that. And another value of this website, it gives you examples. So if you go to something like, let's say, let me choose anything, let's say this power function. If you go to power, it's going to describe in detail all the parameters that are needed. It's going to show you, and what value is returned, and other details of how the function works, if there is any special case and such kind of things. And it is also going to give you an example, so you can really see how something is used. And this is in particular very useful when you start to look for those like more advanced things like vectors, maps, queues, and or files and such things. So very useful website. So as a rule, I can advise you, every time you see a new library, just go to that website, see what the different, you can search for it if you don't see it listed here, and you can see what the library is, the different functions that are inside that library, okay, what it does, and you can look for examples. Okay, this is one of the things that we're going to do in coming videos. Queues, so some advanced data structure right there. Yeah, so before this video goes to like 1 hour, that's a quick overview of these libraries and headers and different ones. So the rest of these videos, we are going to see like different kinds of libraries that are here and dive deeply into what they do, the functionalities that they give you, and help you write better code.